What do Star Trek's Scotty and the X-Men's Nightcrawler have in common? Well, they both have adorable accents, distinctive complexions, and they both have the ability to teleport. In real life, teleportation has been deemed physically impossible. At least it was, until someone did it. I'm Rusty Ward, and I've always wanted the ability to teleport. I want to travel great distances instantly, appear out of nowhere and surprise my opponents, and effortlessly escape from death traps. My favorite X-Man has always been Nightcrawler, because he looked the coolest. Early on, he had the carefree swashbuckler's attitude, and because he had one of the coolest superpowers there is. Teleportation is the ability to move from one location to another without having to travel the physical distance between them. Science fiction has depicted more than one way to accomplish this. Nightcrawler teleports by traveling through another dimension, but I want to talk about the method of teleportation that most closely resembles what we can do in real life. In Star Trek, teleportation is achieved by the deconstruction of an object at one point and the reconstruction of that object at another. For most of the 20th century, this was considered impossible due to Heisenberg's uncertainty principle. No, not that Heisenberg, this Heisenberg. He was one of the key creators of the theory of quantum mechanics. His uncertainty principle said that we couldn't measure quanta, the smallest amount of any physical entity, without destroying it. Put another way, any attempt to examine something would so drastically alter it that it would stop being what it is before we could fully understand it. This made teleportation impossible. We couldn't reconstruct an object unless we scanned it to find out exactly how it was assembled. But the mere action of scanning the object changed it before we could gather all the information we needed. So we were stuck. Until 1993, when 6 incredibly attractive super scientists came up with a way to get around this seemingly insurmountable problem. They used the phenomenon of quantum entanglement. When the quantum states of 2 or more objects become entangled, influencing one object automatically influences the other. This happens even after the entangled objects are separated and placed at great distances away from each other. Einstein referred to this as spooky action at a distance. He called it that because he wasn't a big fan of quantum theory and didn't really believe in quantum entanglement. But it turned out, as the years went by, it was proven again and again to be true. In 1998, scientists used this theory to successfully teleport a photon, a particle of energy that carries light, a distance of 1 meter. There was one slight drawback though, which I'll get to in just a moment. In Star Trek, the transporter room scans a person, breaks that person down into their component parts, transmits those parts to another location, and reassembles them. In quantum teleportation, there's a pretty major difference. This is what happens. You take 3 particles, A, B, and C. If you want to teleport particle A, you first quantum entangle particles B and C. Then separate C and place it where you want A to appear. Then entangle B with A. Then scan the combined particles of A and B. You scan A as well as you can before it's destroyed by the scanning process. You have some of the information you need, but not all of it due to Heisenberg's uncertainty principle. The rest of the information can be found in particle C, because when A influenced B, it also influenced its quantum entangled partner, C. So in order to get all of A's information, you transmit what you scanned to C's location and use it to turn particle C into an exact replica of particle A. Did you pick up the main difference between quantum teleportation and Star Trek teleportation? In quantum teleportation, the original is destroyed and a replica is created. So you would die and be reborn, hopefully with your memories and experiences intact, every time you Bamfed, blinked, or vided. Since 1998, scientists have continued to enhance our teleportation abilities. We can now teleport groups of atoms, and we can teleport distances great enough to reach orbiting satellites. And in 2009, Dr. Romero Isart proposed a way to teleport a virus. He's yet to do it, but he's shown that it's theoretically achievable. We've worked with some particles and a few atoms, but the human body is composed of 10 to the 28th power atoms. That's more than 100 atoms. Students at the University of Leicester figured out that quantum teleporting a human being from Earth into space at standard satellite speeds would take 485 quadrillion years. That's 300,000 times longer than the history of the universe. They didn't just take a person's genetic blueprint into account. The bulk of the information is up here. all the memories and knowledge that make you you is what makes this such a burdensome package. So we're still a very long way from teleporting a human, but although it's very impractical, physicists agree that it's theoretically possible. And that's a very long way from 20 years ago when everyone said it couldn't be done. Thanks for watching. Be sure to subscribe for future episodes and check out some of the previous ones where I break down the science of rage, how to harvest energy from human beings, and how to become immune to poison. And be sure to tell me what superpower you want. I'm out. Exactly as I planned.